Hi everyone, I hope that you're having a good Labor Day weekend. Please review the other slideshow that's been posted on theory. It is pretty easy to read through yourself. All the information is there. It's a great PowerPoint put together by Dr. Fields. And this PowerPoint was also put together by Dr. Fields on conceptualization, operationalization, and measurement. And so we will be going through this today. And then I also ask that you review the YouTube video that I posted a link for. It's just a nice review of some of the stuff that we've already learned and a little bit on theory, just brought to you by a different person. One of the key factors in research is determining how you're going to measure what you are wanting to find out. So what is measurement? It is the process of quantifying states, traits, attributes, behaviors, and concepts. Precise measurement is key for understanding changes in behavior. It's also known as operationalizing or creating an operational definition. Your first step is going to be conceptualizing. This is when we talked about the example related to depression and how you determine which variables you're interested in studying, and exactly what is meant by each variable. So conceptualizing is essentially determining the definition of what you're going to measure, whereas operationalism is specifying how to measure the variables that you have conceptualized. So when it comes to depression, we may have a definition in mind, and in order to operationalize that, we are going to measure things that you all had identified a couple class periods ago, such as indicators to depression like thoughts of suicide, weight loss or weight gain, sleeping more, similar things that typically indicate depression. That is how you're going to operationalize something. Recall that your hypothesis is a testable statement of presumed relationships between two or more concepts, essentially your independent and dependent variable. These concepts need to be well defined in order to be testable. It is important that the independent and dependent variables in the hypothesis are clearly specified, and it is important that the precise nature and direction of the relationship between variables be specified in the hypothesis. What this means is if you have a question or hypothesis, like let's say I think that children who eat breakfast with their parents are more likely to have a positive body image, that is a positive relationship. The more they eat breakfast with their family, the more positive their body image is going to be. So anytime you have things moving in the same direction, even if I would say the less children eat breakfast with their parents, the more negative their body image is going to be. You see how those are still moving in the same direction, so that's still considered a positive relationship because they're going in the same direction. If I were to say children who eat more breakfast with their families are likely to have worse body image, that's going to be a negative relationship, because in this example, eating breakfast with your family is your independent variable, and we are expecting that that causes children to have better or worse body image, which is our dependent variable, because our dependent variable is caused by something. So our independent variable is children eating breakfast with their families, and our dependent variable is body image. When your independent and dependent variable move in the same direction, either negatively or positively, that is considered a positive relationship. If they move in opposite directions, so if one is negative and one is positive, then that's a negative relationship. In order to measure things, you need to have or create operational definitions for both your independent and dependent variables, because we want other researchers to be able to do the same thing that you have done. because remember, we're always trying to build our knowledge base, and we're always trying to prove ourselves wrong in order to build the most amount of evidence that we possibly can to essentially say that what we found is correct or what we found is wrong, and here is 10, 15, 30 other studies that say the same thing. So essentially, you want to define your independent and dependent variables very well so that they can be measured, and then you want to pay attention to those relationships between the two. Let's look at some examples of operational and non-operational definitions. So the first example is one that is non-operational, and you're saying that the participant will read at the 2nd grade level. Okay, great, but what does that mean? What is considered 2nd grade level? Can they answer certain comprehension questions? What kind of questions can they answer? There's all sorts of things that go into understanding what that is. So essentially you want to become more specific. So a good operational definition, instead of that one, would be the participant will read a passage of 100 or more words at the 2.2 grade level with 96% accuracy. And then you'll see that we define accuracy also. So accuracy in reading is understood as the number of correctly read words divided by total number of words. Essentially, you want to define anything that can possibly be ambiguous. So if I'm saying perceptions or behaviors or thoughts, things that are a little more vague and open to interpretation, then you need to be very specific in the way that you're defining it. Some of you talk about resources, access to resources. What I would expect is that you're going to need to define access. Does that mean that it's within a certain mile radius of their house? Does it mean that they have transportation to it? Does it just mean that they have health insurance, that they can actually go there? What does access mean? And then resources, you're going to need to define resources as well. So is that reading? Is it money? What is it that you're defining as resources? Because it can be perceived as many different things. Another note about measuring behavior would be non-operational. The student wanders around. Okay, so what does wandering look like? This is where you're really going to be able to put a lot of your clinical practice to work. Think about when clients are telling you things and the open-ended questions that you're asking them. Essentially, you want to be doing the same thing to your definitions to make sure that you have everything defined. If someone said to you, "My child's in crisis," okay, well, what does crisis mean to you? Because it can mean a lot of different things to different people, right? So we want to know what a crisis means to that particular family. My definition of crisis might be that a child is experiencing suicidal or homicidal ideations, where the family's definition of crisis might mean that they caught their child sending inappropriate pictures to their boyfriend. So we really need to define things so that people aren't misinterpreting your research and thinking that your results are applicable to other things that they're not actually applicable to. Take a second to review the difference between conceptual and operational definitions, and take time to go back to the previous lectures if you need more clarity in understanding these concepts. I think one good way to think about it is a conceptual definition is going to be your definition of what something is, while your operational definition is more of a working definition. How did you define this? How did you measure it for your study? Measurement is a process. It's certainly not always linear, and it can take quite a bit of time to really thoughtfully identify how you're going to measure things. Parts of the process include techniques of measuring, views of measurement, levels of measurement, evaluating measurement, and errors in measurement. We will begin to cover each of these more in depth. The first part of measurement is techniques of measurement, which include where the information comes from. It can come from verbal reports from participants, it can come from observations, or it can come from records such as case notes. It can also be secondary information that other people have gathered. Part 2 is views of measurement, which include what theoretical perspective you're operating from. Go back to the other slideshow and review that to learn more about positivist and postmodern theories, and then as you dive into your research area, you should begin to see certain theories unfold within the literature. One theory that I often come across is attachment theory, which is not a research theory, but it's more of a theory of practice. And so if you think about social work and our theory of practice, it very much is the person and environment mentality and thought process, that the person influences their environment, but also that the environment influences the person. There's many different theories out there, and so as you begin to read different articles, take note of what theories they're using so that you know what is relevant to your field, and then you also don't have to recreate the wheel. Some examples of theories that I use a lot in my research is relational cultural theory, which talks about how relationships really impact people's development, and then taking into perspective the different cultural factors as well that influence development. Other things are positive youth development, which might be applicable for those of you looking at youth who are addicted. Trauma theory is a really good one, especially when looking at addiction. It would also apply to poverty and just other things that are out there. I'll try to find some theories that apply to everyone's research area. Part 3 is levels of measurement. So levels of measurement is a place where we begin to consider outcomes and analysis in the beginning of designing our study. Because the level of measurement we choose to measure by now will impact what kinds of analysis we can conduct on our collected data. There's 4 levels of measurement: nominal, ordinal, interval, and ratio. And you always want to measure as high a level as you possibly can. In your analysis, you can always move down in level, but not move up. So you just want to think about setting up your research to be as rigorous as you possibly can. And then if you're unable to really do that type of measurement, then you can take it a step down. It's much easier, well, it's nearly impossible to conduct a research assignment and then make it more rigorous. You just really can't do that. So essentially just know that you want to start as high as you possibly can, as rigorous as you can, and work your way down. Nominal variables or nominal levels classify observations into mutually exclusive and exhaustive categories. So what that means is that you essentially identify a list of things. So let's use religion as an example. You identify all the religions that are out there, all the different options, and someone can only belong to one. So mutually exclusive and exhaustive. Exhaustive means that you listed every single religion that's possibly out there, and mutually exclusive means that they can only associate themselves with one of those. That may not always be the case when it comes to religion for some people, but for the most part, I think most people typically only identify as one religion. Another option could be socioeconomic status, where you list out all the different socioeconomic statuses and people really only belong to one. They are discrete and they're named. You can't average them. You can't average them because an average, typically you're looking at being able to be part of more than one category, where this one you can't, and so there's no point in averaging things. People either belong to it or they don't. Typically, this is the research that you'll see frequencies and percentages. So frequencies is really just the count of how many people belong in there. An example of a nominal level measurement would be asking people what state they live in. You would have to list out all 50 states separately for it to be mutually exclusive and exhaustive. People can only choose what state they live in, and you're not going to average what state people live in because it just doesn't make sense to do so. But you can certainly list out like 50% of our population lives in Kentucky, or 5 people live in California. That would be an example of including frequencies and percentages. Ordinal level data also resembles nominal in that they are named categories. They're also mutually exclusive and exhaustive, and they have a fixed order. The secret to recognizing ordinal data is that there's a ranking, and the scale is associated with directions, meaning that if something has a higher or lower score, that's actually meaningful to your research. So an example of this would be a Likert scale used to measure depression, where someone rates their feelings of depression on a scale of 1 to 7. It's ordinal because it has an order that matters. As the researcher, you can determine if the 1 or the 7 means more or less depression, but essentially you are ranking it. So if 1 means less depression and 7 means the most depression, you know that if someone chooses 1, that they're not very depressed, whereas someone who chooses 5 or 6 is much more depressed than the person who chose 1. An easier example of this is considering grade level. If you look at grades 1 through 12, that is an ordinal measurement that you would use, because in terms of being mutually exclusive, someone can't be in more than one category. You can't have someone who says that they're in 1st grade and also 7th grade. And it's exhaustive, so you are essentially including grades 1 through 12 if that's what you're interested in. You could include kindergarten, you could include college, but most of the time you'll see maybe kindergarten through 12th grade included. But that each grade level that you go up, so if you start in 1, let's say I identify 1st grade and someone else identifies 7th grade, you know that the person in 7th grade has more education than the person in 1st grade, because that number means something. It's not an arbitrary number like in nominal data. The next level of measurement is going to be interval, which theoretically is infinite number of units with equal intervals between each variable. You will sometimes hear this referred to as continuous variables as well. Interval variables share the characteristics of ordinal scales. They're mutually exclusive and exhaustive categories, and they have a meaningful order. They have an inherent order that means something, but they have equal spacing between categories. Measuring data at this level allows us to get accurate measurements to measure change in small increments. It's required for more robust and sophisticated statistical tests. An example of this variable would be temperature and measuring in Fahrenheit. If you are looking at the difference between 30 and 40 degrees, the difference is 10 degrees, which is also the same for the difference between 80 and 90 degrees. One important thing to note is that interval level data does not have a definite 0 point. So the temperature can be 0, but that doesn't represent the absence of temperature. So just because it's 0 doesn't mean that there's no temperature whatsoever. Ratio is exactly like interval level, but it does have a true 0. So it has all the same characteristics, meaning it's mutually exclusive and exhaustive. It has a meaningful order, but the 0 is absolute and meaningful rather than arbitrary. We can make statements to the effect that some score is a given ratio of another score, and the statistics that are used at this level are often the same as interval level. An example of ratio level measurement would be money and income. So the difference between $25 and $26 is $1, same as the difference between $57 and $58. However, having $0 is actually the absence of money. You don't have any. Whereas in the previous example, having a 0 temperature didn't mean that there was no temperature at all. It just meant that the temperature was 0 degrees. Whereas here, having $0 actually means you have nothing. Here's a great slide to show you that you can measure things differently. So if we look at income, you can measure it at a nominal level or an ordinal level or an interval level or a ratio level. It just matters how you're asking the question and how you're measuring things. In the nominal example, you're just asking someone to say if they have an income or if they don't have an income. In the ordinal level, you have a certain amount of money that differentiates. You also have an order that means something, and it's mutually exclusive and exhaustive, meaning someone can't say that their income is $30,000 and $40,000. At the interval level, we can just ask an open-ended question. What is your income? And at the ratio, it's a little bit different as well. So go ahead and just review these. I think it does a nice job showing you how you can measure things at different levels, even if you're measuring the same exact thing. This slide is a great reminder that you can always start out with the highest level of measurement, which is ratio or interval, and work your way down to ordinal or nominal, but you can't work your way back up. So you can't start at the lowest level of measurement, which would be nominal or ordinal, and then go to the highest levels, which is interval and ratio. So remember that you can always start high and work yourself lower, but you can't start low and move higher. Here's a visual depiction of starting at the lowest level of complexity, which is nominal, and then moving to the highest, which is ratio. It also just breaks down the different levels of measurement into bullet points for you. The fourth part of measurement is evaluating measurement. Evaluating measurement refers to the validity and reliability of a measure. A measure is valid when it measures the construct it was designed to measure. So if you have a depression scale and you're trying to measure anxiety, your measure is not going to be valid because the scale that you chose is not going to measure the construct or concept that you identified. If you want to measure depression, you need to find a scale that has been identified as one that really does measure depression. When you're looking for scales, you will see write-ups about the validity of the scale. Look for those when you're looking to measure things. Reliability is easier to remember because it's most closely associated with how you use the word in everyday life. And a scale or instrument is said to be reliable when it consistently measures the same phenomenon with accuracy. So if you're taking that depression scale to measure depression and you know that it's valid, it also means that it's reliable. It means that it has been tested over and over and over again and has seen the same or similar results, showing that it really does measure depression. So the most important thing for you to remember related to research is that the scale that you're using, the measure that you're using, needs to be clear, reliable, and valid. Take a look at this chart and make sure that you understand that there's different types of validity. There's content validity. Do the test items best reflect the universe of the topic area? Criterion validity, whether the scores are systematically related to other criteria that indicates competence. Does the test reflect a set of abilities? Does the test reflect a set of abilities for the future that's either concurrent or predictive? And that falls under criterion validity. Then there's construct validity, whether the test measures an underlying psychological construct, and you often use theory and research for this. Then there's triangulation, so using multiple sources to see if you find the same patterns or conclusions. And then there's member checking, also known as member validation, or potentially inter-rater reliability. Each one of these shows you a part of validity, and ideally you want your study to be wholly valid using all of these different options. That's not always the case, but if you can find something that has talked about content and criterion and construct validity and has used triangulation or member checking to help, then that's awesome. And please note that triangulation and member checking are just different techniques that are used to increase validity of a study. And you will especially see this in qualitative data, which is sometimes considered to be more subjective. You'll see people using these techniques to make sure that more people are coming to the same conclusion. Like I said before, reliability is whether your measurement tool is measuring consistently what it's supposed to measure. It comes from our observed scores being as close as possible to our true scores. So an observed score is what you see in the reflection of people's answers to your measure, whereas a true score is something that we'll never really know, but it essentially would be the perfect score identifying depression. So one way that I think about it is if you have a depression scale and you have 10 questions, and if you answer it 1 through 10 and your score is a 10, that is your true score. Your purest form of depression would be answering yes to all of the questions indicating that you have depression. Your observed score is going to be what each individual indicates, or what their score is individually. So some of you may have 0, some of you might have 1, or some of you may have 10, and that would be the observed score. You can do this little formula down here at the bottom to reduce error and increase reliability. It's really not necessary for you guys to know that at this point. And it's certainly something that I never learned in my bachelor's program, but just know that it exists and it's something that researchers can do to help increase reliability. So there's different things that you can do to increase your reliability, and these are just 4 of the main ways that researchers will do that. So test retest is just as it sounds. You give someone a test, and then you wait a certain period of time, and then you give it to them again, and you see how consistent they are with each other. Parallel forms is when you want to know if different forms of a test are reliable or equivalent. So you can mix up the order of questions That's typically what you would do. So you would have two different forms that have all the same questions, but just in different orders. And you can make sure that they test the same thing when they're in different orders, and that one question doesn't lead into answering another question a certain way, etc. Then there's internal consistency. So you can use statistics to help determine if your measure is consistent. It's when you want to know if the items on the test assess one dimension. So if you want to make sure that it's only looking at depression and it's not measuring depression and suicidality or depression and substance use, you want to make sure that it's not measuring something it's not intended to measure. And then there's inter-rater reliability, where you have more than one person looking at the data to make sure that they're interpreting it the same way. It's also when you want to know if there's consistency in the rating of an outcome, right? So like I said, you would typically have more than one person look at it. You really see this a lot with qualitative data, where I might go through and find themes and patterns in people's responses, and then I would have one or two of you go through and do the same thing, and we would determine if we came up with similar themes and patterns, and that would be inter-rater reliability. Part 5 of measurement is error in measurement. It's the last part of the process of measurement, is looking at errors in your measurement tool. Error is equal to random errors plus systematic errors, which is that E equals R plus S. Random errors are neither consistent or patterned, and these random errors are assumed to cancel themselves out. Essentially, you would expect to always have some sort of random error in measurement, especially as a new researcher. The more tenure you get as a researcher, the less I would expect to see errors, and especially if you're using a valid measure, then you should essentially be reducing your risk of random errors. Systematic errors are consistent and patterned and do not cancel themselves out. These are a big deal. They can lead to false conclusions. And so you really want to make sure that you don't have any systematic errors. Like I said, random error we can deal with, but systematic error is not good, and you do not want systematic errors in your measurement. So how can we improve our reliability and validity of our studies? Well, we can have more extensive conceptual definitions and development of concepts. We can have better training, and especially train those who will be using the measurement devices. A lot of what we will see at agencies is people who are untrained giving out surveys and helping people do the surveys when they shouldn't be doing that. And just the way that a survey is dispersed, or if you're aiding someone in filling out that survey, you are then increasing your bias and decreasing your reliability and validity of that measure. So it's really important to make sure that you're training the people who will be using the measurement devices. You can interview subjects of the research about the measurement device, ask them what they thought about it. One thing that I am learning with some research that I'm doing right now is that the refugee populations in Tennessee don't really understand measurement tools. Typically, they're not culturally competent. It's not something that the refugees we have here in Tennessee are used to doing, and they find it a little off-putting. And so that is really important to know what your interviewees think about, like what your participants are saying about the measurement tool. You can also use a higher level of measurement. So we can use ratio or interval level, because that's going to help improve our reliability and validity. More indicators of a variable. So variable here is not necessarily referring to independent or dependent variable, it's just referring to what you're trying to measure. So if we're trying to measure depression, that's our variable of interest. Sometimes those words are used interchangeably and it can be confusing. So I will try my best to differentiate, but also just know that they are used interchangeably. So to use more indicators of a variable, so we could ask, in the past 10 days, have you cried more than usual? In the past 10 days, have you lost sleep or slept more than usual? We could ask 2 questions, or we could ask 10 questions that really get at depression. So the more questions you ask, the more valid and reliable your measure is going to be. What you do have to be careful with is that you're not asking too many questions and burning your participant out. And then you can conduct an item-by-item assessment of multiple item measures. And that just means that you're going through and testing the reliability of each individual question that you're asking. The best way for you to improve reliability and validity as a practicing social worker is to just use pre-existing valid instruments. They've already done all these things. You don't have to think about it. Just know that this is what makes it better. And so find measurement tools that are valid and reliable, and you're in the clear. You can find scales in many different places. You will often see them referenced in the journal articles that you're reading. You may also find them in databases such as PsycInfo or EBSCOhost. You can Google or Google Scholar for them, and then you'll see them in books and reference books as well. Just so you know, they're not always free. Sometimes you have to pay for them. I would honestly always try to find a free one because most of the time, especially on depression and anxiety, like really common things, there should be free scales out there, and they're usually just as good as the ones that you have to pay for. If you can't find the instrument that you want, this is something that you might come across. It may mean that you need to narrow your topic down. It may mean that you need to change your search. Also, talk with people who are experts in the field that you're researching. You can attempt to modify an existing instrument. If you do that, you're likely to decrease the reliability and validity of the instrument. But if you're measuring something new, it doesn't really matter, because when you measure something new, your instrument's not reliable or valid yet until multiple people have tested it in different ways to make sure that it really measures what you want it to measure, right? Or you can create your own scale. When I did my research on body image, I had to create my own scale because there was nothing out there. And that's not a problem. It's something that you can do. It takes time. It takes really careful thought and consideration. But I highly recommend doing it if you can't find the instrument that you want. I'm going to let you all read through this individually, and also read Chapter 6 of your book on understanding and using research instruments, because it does a really great overview and will help you really get a more in-depth knowledge of this information. These are the key terms that we went over in today's class, and again, you can find all of this information in Chapters 6 and 7 of your book. So please make sure that you are doing those readings, because your book is great supplemental information, often explains things differently than I do, and so it really can help you enhance your understanding of this material.